So let's explore the unit circle in a little bit more depth. So let's just start with some angle theta. And for the sake of this video, we'll assume everything is in radians. So this angle right over here, we would call this theta. And now let's flip this, I guess we could say the terminal ray of this angle. Let's flip it over the x and y axes. So let's just make sure we've labeled our axes. So let's flip it over the positive x-axis. So if you flip it over the positive x-axis, you just go straight down, then you go the same distance on the other side. You get to that point right over there. And so you would get this ray. You would get this ray that I'm attempting to draw in blue. You would get that ray right over there. Now what is the angle between this ray and the positive x-axis? If you start at the positive x-axis, well, just using our conventions that counterclockwise from the x-axis is a positive angle, this is clockwise. So instead of going theta above the x-axis, we're going theta below. So we would call this, by our convention, an angle of negative theta. Now let's flip our original green ray. Let's flip it over the positive y-axis. So if you flip it over the positive y-axis, we're going to go from there all the way to right over there. And we can draw ourselves a ray. So my best attempt at that is right over there. And what would be the measure of this angle right over here? What was the measure of that angle in radians? Well, we know if we were to go all the way to the from the positive x-axis to the negative x-axis, that would be pi radians, because that's halfway around the circle. So this angle, since we know that if that's theta, this is theta right over here, the angle that we want to figure out, this is going to be all the way around. It's going to be pi minus. It's going to be pi minus theta. Notice pi minus theta plus theta. These two are supplementary, and they add up to pi radians, or 180 degrees. Now let's flip this one over the negative x-axis. So if we flip this one over the negative x-axis, you're going to get right over there, and so you're going to get an angle that looks like this. And now what is going to be the measure of this angle? So if we go all the way around like that, what is the measure of that angle? Well, to go this far is pi, and then you're going another theta. This angle right over here is theta, so you're going pi plus another theta. So this whole angle right over here, this whole thing is pi plus theta radians. So pi plus theta, let me just write that down. So this is pi plus theta. Now that we've figured out these these have different symmetries about them, let's think about how the sines and cosines of these different angles relate to each other. So we already know that this coordinate right over here, that is sine of theta. Sorry, the x-coordinate is cosine of theta. The x-coordinate is cosine of theta, and the y-coordinate is sine of theta. Or another way of thinking about it is this value on the x-axis is cosine of theta, and this value right over here on the y-axis is sine of theta. Now let's think about this one down over here. By the same convention, this point, this is really the unit circle definition of our trig functions. This point, since our angle is negative theta now, this point would be cosine of negative theta, comma, sine of negative theta. And we can apply the same thing over here. This point right over here, the x-coordinate is cosine of pi minus theta. That's what this angle is when we go from the positive x-axis. This is cosine of pi minus theta. And the y-coordinate is the sine of pi minus theta. And then we could go all the way around to this point. I think you see where this is going. This is cosine of, I guess we could say theta plus pi, or pi plus theta. That's right, pi plus theta, and sine of pi plus theta. And now how do these all relate to each other? Well, notice over here, out here on the right-hand side, our x-coordinates are the exact same value. It's this value right over here. So we know that cosine of theta must be equal to the cosine of negative theta. So that's pretty interesting. Let's write that down. Cosine of theta is equal to, let me do this blue color, is equal to the cosine of negative theta. That's a pretty interesting result. But what about their sines? Well, here the sine of theta is this distance above the x-axis, and here the sine of negative theta is the same distance below the x-axis. So they're going to be the negatives of each other. So we could say that sine of negative theta is equal to the negative sine of theta. Equal to the negative sine of theta. It's the opposites. If you go the same amount above or below the x-axis, you're going to get the negative value for the sine. And we could do the same thing over here. How does this one relate to that? Well, these two are going to have the same sine values, right? The sine of this, the y-coordinate, is the same as the sine of that. So we see that this must be equal to that. Let's write that down. So we get sine of theta is equal to sine of pi minus theta. Now let's think about how do the cosines relate. Well, by the same argument, they're going to be the opposites of each other, where the x-coordinates are the same distance but on opposite sides of the origin. So we get cosine of theta is equal to the negative of the cosine of, let me do that same color. Actually, let me make sure my colors are right. So we get cosine of theta is equal to the negative of the cosine of pi minus theta. And now finally, let's think about how this one relates. Well, here our cosine value, our x-coordinate, is the negative, and our sine value is also the negative. We've kind of flipped over both axes. So let's write that down. Over here, we have sine of theta plus pi, which is the same thing as pi plus theta, is equal to the negative of the sine of theta. And we see that this is sine of theta. This is sine of pi plus theta, or sine of theta plus pi. And we get the cosine of theta plus pi. Cosine of theta plus pi is going to be the negative of cosine of theta, is equal to the negative of cosine of theta. So even here, and you could see, you could keep going. You could try to relate this one to that one, or that one to that one. You can get all sorts of interesting results. So I encourage you to really try to think this through on your own, and think about how all of these are related to each other based on essentially symmetries or reflections around the x or y axis.